Welcome to homework.
Okay, we have the following molecule, which I will sketch out. And the first thing that we want to do when we're naming a molecule like this is identify the longest chain. It's not too hard to see that if we start at the right-hand side, the furthest we can go, and end at the left-hand side, the farthest we can go, that we could number the chain something like this: 1, 2, 3, 4, 5, 6, 7, 8, like so. Right? We could explore some other numbering options, but this is clearly the longest. Don't get thrown off by the alkyne, right? This is a carbon and that's a carbon. Okay, so we have an 8-carbon chain. Now, one thing that we need to consider is whether we want to number this from the left or the right. That is, we could have 1, 2, 3, 4, 5, 6, 7, 8 coming from the right, or 1, 2, 3, 4, 5, 6, 7, 8 counting from the left. Sometimes this does make a difference, right? And so the way we would compare this is determine which counting direction would give us the lowest numbering on our substituents, right? So we've determined that we have an 8-carbon chain and that it's an alkyne, but our substituents are in fact these methyl groups, which I'll highlight now. That's a methyl group. That's a methyl group. This is a methyl group, and this is a methyl group. Now, if we count from the left, we hit our first methyl group at 3, right? 1, 2, 3. If we count from the right, we hit our first methyl group at carbon 2, 1, 2. And we always want to pick whichever direction will give us the lowest number for our substituent, right? And so in this case, that means counting from the right, which is what we're going to do. So let's start then with the base name of our chain and the fact that it's an alkyne. We're counting from the right to left: 1, 2, 3, 4. We have an 8-carbon chain with an alkyne at carbon 4. So that becomes, in terms of a base name, oct for 8. Then we denote the position of the triple bond, the alkyne, oct 4 ine. Okay, so that's sort of our base name. And then all we have left to do is assign the substituents that we have. So we have a methyl at 2, a methyl at 3, and 2 methyls at carbon 6, right? So that would be written out: 2, 3, 6, 6 dash tetramethyl. And there's one other component to consider, and that is that we do have a stereocenter at carbon 3. So we need to determine if this is R or S. For that, I like to draw in the hydrogen. Let me clear some of these other things out of the way just to make this a little smoother. Right, so if we consider that we do in fact have a hydrogen here, and we see that our hydrogen is in the front. Sorry, let's draw an 8. Draw a 4. Okay, so if our lowest priority substituent is in the front, right, this is our lowest priority substituent, then clockwise is S and counterclockwise is R. That's my the way I handle these is I look at whether the lowest priority substituent is in the front or back, and then determine R or S and its relationship to clockwise or counterclockwise from that. One frequent way to do it is to just always rearrange the molecule and put the lowest priority substituent in the back, but I find that to be a little more confusing. So I'll say lowest substituent not in back means that clockwise is S and clockwise counterclockwise is R, right? That's only true when our lowest priority substituent is not in the back. Now let's number the remaining substituents. So our options are a carbon, which is attached to 3 hydrogens, a carbon, which is attached to 1 hydrogen and 2 carbons, and a carbon in a triple bond counts as being attached to 3 carbons: 1, 2, 3. So we've got hydrogen, 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 carbon, carbon, hydrogen, and carbon, carbon, carbon. Carbon, carbon, carbon is a higher priority than carbon, carbon, hydrogen. So this is priority 1, this is priority 2, and this is priority 3, right? Hydrogen, hydrogen, hydrogen is slower than carbon, carbon, hydrogen. So then we connect 1 to 2 to 3, 1 to 2 to 3, and that is clockwise, which when the lowest priority substituent is not in the back means S. So our molecule is S. So putting it all together, we have, do it in black here so it's more legible, S dash 2, 3, 6, 6 dash tetramethyl no space or dash anything between the last substituent group and our group name, oct 4 9.